Hi there, in this video I'm going to talk about parametric equations, okay? So let me title this parametric equations. So let me take a red pen and a ruler, underline this. So the term parametric equations, basically parametric equations are equations for x and y in terms of a third variable. Okay, so let me just say that these are equations for x and y in terms of a third variable. Okay, so let me give you some examples of parametric equations. So in this case, if I have x equals 2t and y is equal to t cubed, so here's one set of parametric equations. So over here I've got two equations for x and y in terms of a third variable, and the third variable being t. Okay, part B, let me give you another example. X equals 2 sine theta and y is equal to 3 cos theta. Again, another example of a set of parametric equations, since I have equations for x and y in terms of a third variable, and the third variable being theta. Okay. Now, it is possible to get rid of the third variable in order to get one equation in terms of x and y only. And the one equation in terms of x and y only is called the Cartesian equation. So what I'm trying to say is, by eliminating the third variable, okay, we have one equation in terms of x and y only, and that equation is called the Cartesian equation. Okay, so if you get rid of the third variable, you have one equation in terms of x and y known as the Cartesian equation. So let me show you how to get the Cartesian equation from the parametric equations. So here's an example, example number 1. So let me take a red pen and underline this. So question is to find the Cartesian equation, and here's an example. Here's a part A. So first equation for x, x equals t minus 1. Equation for y, y is equal to 2t squared plus 1. Okay, so remember, to get the Cartesian equation we need to get rid of that third variable, and the third variable is t. Okay, so it's quite straightforward. What I normally do is I name my equations 1 and 2, okay? And what I do is I take one equation and rearrange for the third variable t. So if I take equation 1 and if I rearrange for t, so using equation number 1, so x is currently t minus 1, but if I rearrange, t is going to be x plus 1 when I rearrange equation 1. And simply, if I put t is equal to x plus 1 into equation 2, so in other words, if I replace t in equation 2 by x plus 1, we'll therefore get the Cartesian equation. Okay, so put t is equal to x plus 1 into equation number 2. So by doing this, we're going to have y is equal to 2 into t which is x plus 1 squared plus 1. Okay, so this equation that we've ended up with, this is an equation in terms of x and y only, and according to the definition, this equation in terms of x and y only is our Cartesian equation. Okay, so remember, we started from parametric equations, so here are the parametric equations, and we've ended up with one equation in terms of x and y only by eliminating the third variable t. And remember, this equation that we have now is the Cartesian equation. Okay, let's try another example. So let me try another example. So on the reverse, part B. So let's get the Cartesian equation from this set of parametric equations. First equation reads x equals 2t plus 1. Second equation for y is equal to 1 over t squared plus 2. Okay? So let's see what we did earlier. So in part A, I took one equation and I rearranged for t, the third variable, and then I replaced the third variable in the remaining equation, okay, to get the Cartesian equation. So let's follow the same approach for part B. So I'm going to name my equations 1 and 2, just as I did earlier in part A. And I'm going to take equation 1 and rearrange for t. So using equation number 1, so if I rearrange equation 1, so currently x is 2t plus 1. So if I rearrange, t will be x minus 1 divided by 2. Okay? Now, if I replace the t in equation 2 by x minus 1 over 2, we're going to get the Cartesian equation. So if I put t is equal to x minus 1 divided by 2 into equation number 2, we're going to have y is equal to 1 divided by t, which is x minus 1 divided by 2, and don't forget to square, so squared, plus 2. Okay? So in this case, if I simplify this, I'll have y is equal to 1 divided by, so x minus 1 squared divided by 2 squared is the same as x minus 1 squared divided by, and 2 squared being 4, plus the 2. Okay? And what I'm going to do is, if you cast your eyes to this denominator term, okay, which I've highlighted using a red pen, and if I take a common denominator of that term of 4, okay, so if I continue alongside, so what I'm going to do is, looking at this term highlighted in red, I'm going to take a common denominator of 4 from that term. So by doing that, we're going to end up with x minus 1 squared plus an 8. Okay? And if we simplify this, okay, so the 4 will come on top. So that's the same as 4 over x minus 1 squared plus 8. Okay? So this, therefore, there is one equation in terms of x and y only, hence our Cartesian equation. So here are just some examples of how to get the Cartesian equation from a set of parametric equations. Okay? Let me show you how to get the Cartesian equation if you have a set of parametric equations in terms of trigonometric functions. Okay, so let's have a look at this prepared screenshot. So in this screenshot, what I have is I've got a table. So in the first column, I've titled that Parametric Equations. Second column, I'm giving you an idea in terms of what identity that you need to use in order to help you get the Cartesian equation. And I'll have a third column giving you an idea of the geometric shape that the Cartesian equation gives you. Okay? So in the first case, if your parametric equations are in terms of sine thetas and cos thetas, okay, so where thetas, the angles are the same, the identity, the trigonometric identity in particular that you'll have to use is the fundamental Pythagorean identity. So you'll need to use cos squared theta plus sine squared theta is equal to 1 in order to help you get the corresponding Cartesian equation. Okay? Now, the shape in terms of the Cartesian equation, so when you get the Cartesian equation, the geometric shape that the Cartesian equation gives you is the equation of a circle of radius r. Okay? So that is the first case. In the second case, if you have parametric equations in terms of sec theta and tan theta, the identity that you'll need to use in order to help you get the Cartesian equation is 1 plus tan squared theta is equal to sec squared theta. Okay? And I've given you the geometric shape that relates to the Cartesian equation that you'll get. And if you have parametric equations in the third case in terms of double angles, okay, so if you have in the first instant an equation in terms of cos 2 theta and the other equation for x or y in terms of sine theta or cos theta, you'll need to use the double angle formula for cos in order to help you get the corresponding Cartesian equation. And in the next case, if one of your parametric equations for x or y is in terms of the double angle for sine, okay, that means that you'll need to use the double angle formula for sine in order to help you get the corresponding Cartesian equation. And finally, if you have parametric equations for x and y in terms of cot of an angle and cosec of the same angle, in that particular case you'll need to use the identity 1 plus cot squared theta is equal to cosec squared theta in order for you to get the corresponding Cartesian equation. Okay? So to summarize this table, in order to get the Cartesian equation from a set of parametric equations containing trigonometric functions, always think about an identity, a trigonometric identity connecting your two trigonometric ratios in your parametric equations in order to get rid of the angle term. Okay, so for example, in the first instance, so if you have equations for x and y in terms of sines and coses, think about one identity connecting the sine and the cos term. So the one that connects the sine and the cos term is the fundamental Pythagorean identity cos squared theta plus sine squared theta is equal to 1. And by using that identity in some part of your calculation, you'll be able to remove or get rid of the angle term in your parametric equations. Okay? Now, back to the paper and pen. Now let's try some examples. So let's try some examples whereby we need to calculate the Cartesian equation from the following parametric equations containing trigonometric functions. Okay, so here's an example. I'll call this example 2. Take a red pen, underline this. So question is to find the Cartesian equation. So remember, by Cartesian, remember it's one equation involving x and y only. And let's work out the Cartesian equation. And the given parametric equations are x is equal to 2 sine theta and y is equal to 3 cos theta. So remember, if we go back to the table, so remember, if your equations involve sines and coses, you need to think about one identity connecting sine and cos in order to remove the angle term, which is theta in our case. Okay? So here is step number 1. So I have x is equal to 2 sine theta, y is equal to 3 cos theta. So in step 1, let me rearrange for sine theta and cos theta. So let me rearrange. So if I name these equations 1 and 2 respectively, if I take equation 1, sine theta when I rearrange will be x over 2. And if I take equation 2 and if I rearrange for cos theta is y over 3. Okay? So that is 1 and 2 rearranged. Now, in order to use the identity involving sine and cos, so the identity for us in this case is cos squared plus sine squared is equal to 1, we need to square these two equations and we need to square on both sides. Okay? So let me square equations 1 and 2 on both sides so that we can use the trigonometric identity. So let me write down the step. So by squaring equations 1 and 2 on both sides. Okay, so if I take equation 1 and if I square on both sides, on the left hand side we'll have sine squared theta, that's equal to, and on the right hand side x over 2 squared is x squared divided by 4. So I'll call that equation 3. If I do the same for equation 2, if I square both sides, left hand side is going to be cos squared theta, that is equal to, on the right hand side, y over 3 squared, that's the same as y squared over 9, we'll call that equation 4. Okay, so that's our step 2. So the identity, remember, that we're going to use is cos squared plus sine squared is equal to 1. So in the next stage I'm going to add equation 3 to equation 4 so that we can use the identity. So if we add equation 3 to equation number 4, so if I add, the left hand side is going to be sine squared theta plus cos squared theta. So remember, according to the identity, that equates to 1. And on the right hand side, when we add, we'll have x squared over 4 plus y squared over 9. Okay, so our Cartesian equation therefore will read x squared over 4 plus y squared over 9, and that's equal to 1. Okay, so that completes part A. So let's try another one. So on the reverse, let's try a part B. So if our parametric equations for x and y are, so x is equal to, let's say, sine 2 alpha, okay, and y is equal to cos alpha. So let me show you how to get the Cartesian equation from this set of parametric equations. So first things first, let me name these equations 1 and 2. Okay? And now, if we go back to the table, one of our equations is in terms of a double angle. Okay? So primarily, equation number 1 is x equals sine 2 alpha. So that involves the double angle for sine. So that means to us that we need to use the double angle formula for sine in order to help us get the Cartesian equation. So in step number 1, we're going to have x equals sine 2 alpha. But if I use the double angle formula for sine, so the double angle formula for sine, if you remember, sine 2 alpha is 2 sine alpha cos alpha. I can rewrite equation 1 as x is equal to 2 sine alpha cos alpha, and equation 2, let me keep it as it is, y is equal to cos alpha. So let me keep it as it is for now. Now, our equations 1 and 2 are in terms of sines and coses. You need to use an identity containing or involving sine and cos. So the identity involving sine and cos is cos squared plus sine squared is equal to 1. So somehow we need to use the identity in order to get our Cartesian equation. So since that identity has a square, it makes sense for us to square both sides of these two equations 1 and 2. So that's what I'm going to do in my next step. So by squaring equations 1 and 2 on both sides. So if I take equation 1 and if I square on both sides, on the left hand side we'll have x squared, and on the right hand side, if I square that term, 2 squared is 4 sine squared alpha cos squared alpha. Okay, so I'll call that equation 3. And if I do the same with equation 2, if I square both sides, I'll have y squared on the left. Squaring the term on the right will give us a cos squared alpha. Let's call that equation 4. Okay? Now, remember, somehow we need to use the identity. So let me take a red pen. Cos squared plus sine squared is equal to 1. So somehow we need to apply the identity. Now, we have equation 1, which is x squared, and that is 4 sine squared alpha cos squared alpha. Equation 4 is y squared is cos squared alpha. So we're halfway there. We can replace this cos squared alpha by y squared. However, we need to deal with the sine squared alpha term. Okay? So that is where this identity is going to be useful. So if we rearrange this identity, so if we rearrange for sine squared alpha in terms of cos squared alpha, we can replace all of the cos squared alpha terms by y squared. Okay? So let's do that. So if I take that identity, so in this case, in my next step, our identity is cos squared alpha plus sine squared alpha is equal to 1. And if we rearrange for sine squared alpha, we're going to have sine squared alpha is 1 minus cos squared alpha. Okay? And further to that, if I replace the sine squared alpha by 1 minus cos squared alpha, we're going to have x squared, and that's equal to 4 sine squared alpha, which is 1 minus cos squared alpha, into another cos squared alpha. Okay, and you can call that equation number 5. And equation 4, let's keep it as it is. Y squared is cos squared alpha. Okay, and now it's just a case of replacing the cos squared alpha terms by y squared to get the Cartesian equation. So since cos squared alpha is y squared, so if we do the replacement, we're going to have x squared on the left, that's equal to 4, open a bracket, 1 minus cos squared alpha, which is y squared, multiplied by, and cos squared alpha again is y squared. So here's our equation involving x and y only, so hence this is our Cartesian equation. Let's try one more. So part C. So in part C, x is equal to 3 tan beta and y is equal to 2 sec beta. So remember, think of a trigonometric identity in order to get rid of the angle term, which is beta. So let me start off by naming these equations 1 and 2. So let me name them 1 and 2, okay? And in step number 1, let me rearrange these two equations. So let me rearrange for tan and sec. So tan beta, so if I rearrange equation 1, that's the same as x over 3, okay? So that's our equation 1 when rearranged. And if I rearrange equation 2 for sec beta is y divided by 2, so we'll call that equation 2, okay? Now in the second step, let's think about the trigonometric identity that we can use in order to get rid of the angle term beta. So one of the identities that we can use is 1 plus tan squared is equal to sec squared. Okay, so we can use that identity in order to get rid of this angle term, which is beta. Okay, so let me make a note of the identity. So we're going to be using somehow 1 plus tan squared, that is equal to sec squared. Okay, so once again, you can note from the identity it contains a square, so we need to square as a result both of these equations 1 and 2 on both sides in order for us to use this identity. Okay, so in step number 2, let's square. So by squaring equations 1 and 2 on both sides. So if I take equation number 1 and if I square on both sides, on the left I'll have tan squared beta, that is equal to, on the right, x over 3 squared is the same as x squared over 9. So I'm going to call that equation 3. Okay. If I square equation 2 on both sides, on the left we're going to have sec squared beta, that's equal to, on the right hand side, y over 2 squared, same as y squared over 4. So I'll call that equation 4. Okay? So that takes us to the next step, step number 3. Okay? So in this case, looking at this identity, 1 plus tan squared equals sec squared. Okay? So you can do this in a number of ways. What you could do is you can calculate sec squared minus tan squared. So sec squared minus tan squared gives you 1 according to the identity. Okay, so if you take the identity, so what I'm trying to say is when you rearrange the identity, sec squared minus tan squared beta is 1. So if you calculate equation 4 minus equation 3 and apply the identity, you're going to get your Cartesian equation, okay? Or you can just as well write your identity. So we're going to be using 1 plus tan squared beta equals sec squared beta. So you can write your identity and then replace the terms. So we're going to have 1 plus tan squared beta from equation 3 is x squared over 9. So let me replace that by x squared over 9. And that's equal to sec squared beta is y squared over 4. So let's replace that by y squared over 4. And this is your equation involving x and y only, hence the Cartesian equation. Okay? So that completes part C. So that ends this example, and that ends the examples on getting the Cartesian equation from parametric equations. So I hope you enjoyed this video. Do related practice questions. If you did enjoy the video, a like would be very much appreciated, and I hope to see you soon. Thank you.